इसलिए नहीं करते क्योंकि वो इन्फॉर्मेशन ले लेगा क्या?
एक मिनट, एक मिनट। Okay, guys, we'll start with the session today. So, in the previous class, we were talking about RAG. We got an introduction to RAG, and we will continue our discussion from there. But we'll do a quick revision of everything that we talked about in the previous session. So, we saw that RAG, it stands for Retrieval Augmented Generation, but we did not go into what is RAG, but rather we were discussing about the problems that the RAG solves. So we talked about a general generation process where we have a LLM, and all of us use this process where we have a LLM, we give a query and we get a response. This is how usually how we interact with a chat GPT or Claude or any other chatbot that we see in our day-to-day life. This is how usually we work, or this is how usually we have been working. But there are some obvious problems or challenges, and we discussed about the problem of the cutoff date, which means that whichever LLM we interact with, in fact, most of us use ChatGPT or Gemini, Claude. They all have a cutoff date of training, which means the model keeps getting updated, but the model gets updated maybe once in 6 months or once in a year. So there is always a cutoff date. For example, if today is 25th January 2026. So if today you go to ChatGPT, it does not have the information up till the point, up till the date in which you are querying the LLM. It might have knowledge maybe 5 months. Its cutoff date might be 5 months behind the current date, or it might be 1 year behind the current date, or its cutoff date might be somewhere in October 2025, something like that. So there is always a cutoff date of training, and it knows about the information on the internet that was present up till the cutoff date, right? Then there is the problem of private data, which means the LLM does not have access to your private data, and LLM does not have access to any data that is not public. Okay, so if you have started your company after ChatGPT got launched, then ChatGPT does not know about your personal information or any development that has happened. If I ask ChatGPT about what is the weather of today, or if there was a cricket match last night, what was the result, it might not be able to tell you the answer. It might give you an answer these days because it has access to the internet, and it can make a search on the internet and it can fetch you the result. But the LLM itself, the parameters of the LLM itself, they don't know the latest information. Navneet, you were saying something about private data.
वो इन्फॉर्मेशन ले लेगा, इसके वजह से हम लोग इसको यूज नहीं करेंगे क्या प्राइवेट डेटा में?
क्या?
जो फाइनेंशियल रिकॉर्ड में लैक ऑफ मतलब इंफॉर्मेशन शेयर करना नहीं रहता ना, उसको सिक्योर करना रहता है ना, इसके वजह से।
जी, जी, जी। ठीक है. So in order to solve this problem, we talked about two solutions, possible solutions. One was a fine tuning solution, the other was a RAG solution. Then we discussed a little bit about what is fine tuning. A very quick summary is that a fine tuning is kind of training the model again, but of course we are not training the entire model. We are using the general knowledge that the model has, but we are kind of polishing it on the last possible layers of its information. And I gave you the example of how you might study from your LKG, UKG up till your 10th standard. But when you go to your 12th standard, you are using all the information from LKG up till 12th standard. But then you are doing some fine tuning because you might go into maths. So person who goes into math stream, he does a little bit of specialization. He learns about math. Someone who goes into the biology stream, he learns little bit about biology. So they all are using some common knowledge what they have learned from LKG up till their 10th or 11th standard, and then on top of that they are doing some kind of specialization. Okay, so that kind of training, okay, is called as fine tuning. And we did not want to go deep into how fine tuning is. Fine tuning is in itself a separate subject. Okay, and then we talked about what are the challenges with fine tuning. For example, it is expensive, and it needs expertise. Okay, you cannot just fine tune a model, you need to understand how LLMs are trained, and there are some APIs for fine tuning also, but usually this is not the route that we are taking. And after that we started talking about RAG, and I told you RAG, I give you the example of how RAG is like an open book examination where you get a question and you find a book and you find the relevant chapter in the book, and from that relevant chapter you get some information, and then you use your general knowledge plus the context that is coming from the book, and you mix and match all of that, and then you are able to come up with a answer, right? So I hope all of you have seen the last video. If not, the recording will be there in your dashboard, you can try that out. But high level summary is that RAG stands for retrieval augmented generation, which means we are doing the general generation, we are passing something to the LLM, and we are getting the response. but there is a difference in what we are passing. We are not just passing the question, we are also passing some context. What is this context? This context is some relevant information about the question that is going to help the LLM answer the question better. And where is this context coming from? This context is coming from some knowledge source or some documents. So we are taking some documents. From those documents, we are creating a knowledge source. That knowledge source is helping find out some context, or some, you can say, like some hint, which is going to help the LLM answer the question. Then we are passing the question and we are passing the hint. It goes to the LLM. The LLM uses its general knowledge plus the context in order to answer the question, and we are getting the response. Okay. And then we are trying to conclude with some questions like, how is this relevant information fetched? What is the process? How are we going to fetch the information? So when I gave you the example, I conveniently gave you example of an open book examination, because if we are in a exam, we can find out which chapter is related to which question, and we are able to take out the context. But how does a LLM do it? Okay, so that was one question. And the question was, how do we find the right context? And the second question was, how will question plus context be given to the LLM? So this, I told you, this is the augmentation process, and this is a retrieval process. And retrieval augmented generation is what is RAG, correct? And then we discussed a little bit more about how we take documents. From the documents, we create the knowledge base. How this happens, we did not discuss, but we figured out that there is some process from documents to create this knowledge base. And this knowledge base will take the question and it will give the context. This question will go back and get added to the question. This context will go back and get added to the question. And both of these will go to the LLM, and LLM is going to give us a better response. Today, we will try to do one practical implementation of this so that you are very, very clear on how this happens. Okay. And we talked a little bit about how this knowledge base, or how this document is used to create the knowledge base. And we just had a small introduction on what is an embedding. So this is the concept of embedding. I did not introduce this word yesterday, but we talked about a numerical representation of the document. So what we are going to do is figure out a way, some way, in which this document, so we were talking about the example of how LLM can figure out what is Rajiv's favorite food. Rajiv's favorite food is not a general knowledge, so LLM does not know it. So this question is going to go to the knowledge base, and the knowledge base is comprised of a biography of Rajiv. So we have personal information of Rajiv, education, hobbies, work, family, all of this. And out of these, we will figure out the relevant information which is about food, and that information will go in the context, and that is going to help the LLM to give a augmented response. Okay. So this is what we discussed last time, and we left the discussion at this question, which is how retrieval happens. And we will resume today's discussion on this question, how retrieval happens, and we will talk about a high level concept, high level intuition of uh, embeddings and the retrieval process. Okay, so that is the agenda for today. I'll try to explain how embeddings work, what are embeddings, and we'll not go into too much mathematical detail of how embeddings happen or how those models are trained, but just to understand on a very intuitive level what embeddings are, what is the role they play, and how retrieval happens. If we know how retrieval happens, then we will be able to understand other things also. Okay, so is everyone with me up till here? All of you are clear on everything we discussed yesterday? Just give me a yes in the chat, please. Okay, chalo. So let us talk about embeddings. Have you guys heard about this term, embeddings? Anubhav, you are having some doubts? Yes, we'll do some Q&A after maybe 1 hour. We'll discuss till 4 o'clock, 40 minutes, 30-40 minutes, and after that we can have a little bit of discussion. Embeddings. So what is the purpose of embeddings? Again, we'll not try to understand embeddings directly. We'll try to understand what problem will embedding solve. Okay. So let me. I told you about the entire process of RAG. Okay. So entire process of RAG means that there is a retrieval and there is augmented and there is generation. Okay, so today we are going to focus on this part, retrieval process. So what is this retrieval process? What does it do? What is the job of this retrieval? The job of this retrieval is to take documents. Okay, we will have some documents. These documents can be like PDF files, text files, etc. Okay, we'll take these documents, and from these documents we are going to create a knowledge base. I'm using the word knowledge base again and again. Okay, after some point I will stop using the word knowledge base, and I will use the word vector database or vector store. But right now I'm using the word knowledge base. Okay, so this knowledge base, you might say that what's the difference between this documents and this knowledge base? This document is also containing the knowledge. Okay, but there is some small difference, that if you have a document, okay, you cannot directly find, or you cannot directly retrieve from this document. I'll tell you why. What do I mean by that? I'll tell you in a while. But let us first understand this process. We have document, we have knowledge base, and from this knowledge base, we'll have the job, okay, of taking in a question. We can give a question to this knowledge base, or we can give a query to this knowledge base, and this knowledge base is going to help us retrieve. So this process I will call it as retrieve. And what we are going to get here is called context. Okay, this is the process. So we are going to understand, this is the entire thing. This entire thing I'm going to call as, sorry, this entire process I'm going to call as a retrieval process. And within this retrieval process also, I'm going to focus on this part. In fact, we are going to focus on the entire thing. So let us try to first understand the problem. The problem is that, suppose I'm having a document. I'm having a document that Rajiv likes pasta. Okay. I'm having a document called Rajiv likes cricket. Okay. And I'm having a document called Rajiv is a engineer. Okay. And I will say Rajiv is married. Okay. Suppose these are the 4 sentences I have. So suppose this is my document. This is my document. This is maybe a biography of Rajiv, or it is a PDF file. It is maybe uh, a, a, a web page, or maybe extract from some book or whatever. Okay. Now, my job is that if I have a question, say, what is Rajiv's favorite food? Okay. And based on this question, I want to find out what is the relevant information in this document which is going to help me answer this question. Or I will simplify it a little bit. I want to find out which part of this document, which part of this document is relevant to this sentence. For example, if I'm talking about Rajiv's favorite food, then definitely this sentence, which says that Rajiv likes pasta, is relevant to this question. Or I'm going to say that which sentence or which part of this document is similar to the question that is being asked. So I'm talking about similarity. Okay. And this similarity is not just any similarity, this is semantic similarity. Semantic similarity. For example, if I say sports and football, can I say that sports and football are semantically similar because sports and football is a sport? type of sport. Wherever you will talk about sports, maybe you will talk about football. Wherever you will talk about football, you'll probably talk about sports. You can say, maybe I can take a word called fitness. Can I say that fitness is somewhat related to sports? If I talk about health, can I say that yes, health is also related to sports? But if I talk about uh, tiger, is tiger related to sports in any way? Okay. If I talk about maybe elephant, or let me talk about uh, Dubai, or let me talk about camera. Okay. If I talk about similarity, okay, which of these words will you say is similar to sports? If I ask you to give a ranking or a percentage, can I say that football is definitely maybe 95% similar to sports? Semantically, semantic, I hope you understand the meaning of the word semantic. It pertains to meaning of words. Okay. If I talk about football, maybe I'll say 95%. If I talk about fitness, maybe 90%. Wherever you will talk about fitness, maybe there will be some discussion about sports also. So they are somewhat similar. Okay. Or I'll say they will appear in similar context. In NLP, whenever we talk about similarity, we talk about contextual similarity. Contextual similarity means wherever these words will appear in similar context, or in similar neighborhood, or in similar articles, you will see these words together. Okay. But if you talk about camera, maybe sports and camera is not going to come together. So maybe this will have only 50% similarity. Okay. Maybe if there's a document about hobbies of people, there you can see, okay, someone can be interested in sports, someone can also be interested in photography. So there, sports and camera can come together, but otherwise, usually, sports and camera is not going to come together. Sports and health can come together. Okay. Maybe this is 92% similar. Okay. Sports and tiger, I don't think so. Maybe 30%. Okay. Sports and Dubai, maybe 40%. Some sports is happening in Dubai. Okay. So here I'm talking about a similarity score. So how are we going to find out a similarity score? Because we want to find out which document here is similar to this sentence. So here we are talking about food, we are talking about Rajiv, right? And here there is a discussion of pasta, cricket, engineer, marriage. Okay. There can be some other sentences also. Okay. So what is a way in order to compare these sentences? And if there was a way in which I could assign some similarity score to these sentences, okay, then I could filter that out and find out which sentence is having the maximum possible similarity, right? And I could take that out and I can say that, okay, this sentence is similar to the question, therefore this can become my context to the LLM to solve the question that has been asked. All of you have understood what I'm trying to say till here? What is the problem? Have you understood the problem? Okay. So here is the solution to the problem. We say that if there was a way, okay, if there was a way in which we could similarity, if we could convert words to a numerical representation, or we'll say vectors, then we can compare two vectors and find distance. This distance, we can say that if distance is less, that means their similarity is high. If the distance is more, or if they are far away, then we will say similarity is less. Now the question is that how are we going to convert the words to a numerical representation? Again, see, all of this happens when you learn about RAG and all. You know a little bit of NLP, you learn a little bit of deep learning, you do machine learning, then you are reaching here. But we have arrived here out of nowhere. We don't have much context of NLP. We have not learned many things. Okay. So I'm trying to oversimplify this so that you get an intuition. Once you get an intuition, later on you can also get a lot of mathematical depth out of it. Okay. But I will try to give a very simple explanation of how this numerical representation might happen. Okay. The actual process is little complicated, but I'll try to show you one intuitive way in which these vectors can be represented. And then I'll give you a demo, practical demo of how these numbers actually make sense. Okay. So first of all, I'll try to explain what I mean by these vectors. Okay. What is the meaning of these vectors, numerical representation or vectors? What are we trying to achieve? Okay. If we understand what, then later on we can understand how those numbers are coming, that we can understand later also. Okay. So what I mean to say is that, you see, if I draw a 2D plane, okay, and if I say this is the x coordinate and this is a y coordinate, okay, and if I draw one point here, I hope all of you understand the basic concept of distance. Okay. So if I draw one point here, okay, and if I draw one point here, maybe this point, let me zoom it. Okay. So let me say that this point is belonging to Apple. Okay. And I'm making another point here. Okay. And this point is corresponding to a banana. Okay. And I'm making one more point here. And this point is corresponding to what do I say? Maybe football. Okay. So by looking at this graph, can you say that because apple and banana are close to each other, they are close to each other. Okay. Can I say that apple and banana are similar to each other? Because they are close to each other. Now, this point is going to be represented by some numbers. I have written here apple and I've written here banana, but actually there will be some coordinates. There are going to be some numbers for these. Um, there are going to be some numbers for these coordinates. So, for example, if you have apple, maybe the coordinate for the apple is 2 and 5, and the coordinate for banana is maybe 5 and 8. Okay. And the coordinate for football is maybe 15 and 9. Okay. So these are the three coordinates. So this is what I mean by number being represented, a word being represented by numbers. So this, I can say this is the array of numbers. I can say this is 2 and 5. Here this is 5 and 8. And here this is 15 and 9. Now, from where these numbers are coming, right now I'm just imagining and I'm giving you imaginary numbers. But there is a system by which we can get these numbers. And the job of these numbers, why are we converting it to numbers? The job of these numbers is to realize the meaning of the word in the numerical form. Okay. So when we say that two words are similar to each other, okay, we say two words are similar to each other, we are saying that in our natural language understanding, okay, based on our training, we know that, okay, apple and banana are similar to each other. But if a machine has to decide if apple and banana are similar to each other, machine needs to have some numbers, and those numbers need to convey the meaning of the word. This might sound very bizarre, that how can numbers convey the meaning of the word? But in reality, that is how things work. That's how ChatGPT or any LLM that you work with, they work. Because ultimately they are a bunch of numbers. But those numbers somehow, in an interpretable or a non-interpretable way, those numbers actually contain within themselves the meaning of those words. Okay. How those numbers are achieved is a separate discussion. We'll not get into that. But we for sure know that there are vector representations which actually contain the meaning of the word. Here I'm drawing it in a very, very simple two-dimensional plane. But actually, if you look at vector representations, that they can have maybe 1,000 or 1,500 dimensions. Okay, which is not possible for us to draw. But ultimately, they are a bunch of numbers. Here I have an array which is having only two numbers. In reality, this might be an array which is having 500, 300, 900, 2000, whatever length it can be there. But the purpose of those numbers is to convey the meaning of the word. If those numbers contain the meaning of the word, then similar words will have similar vectors. Similar words will have similar vectors, and words which don't have any similarity, they will have vectors which are very far away from each other. Okay, so how we measure this is by using angle between these words. We don't refer to the magnitude, but we refer to the angle between these words. So here, if you see, there is this angle. Okay, this angle is very less. But if you look at this word, if you look at football, you'll see that this angle is much higher, which means that banana and football are far away from each other. Apple and banana are close to each other. Apple and football is also far away from each other. It is determined by this angle. This type of similarity is called as cosine similarity. Okay, cosine similarity or cosine distance. Okay, so if cosine similarity is high, then cosine distance is low. If the cosine, sorry, opposite I'm saying. I'll give you small intuition of how we might achieve these numbers, but I hope the takeaway idea is that we are going to convert words to numbers. Okay, how that happens, I'll give you a small example, but practically how that happens is slightly out of scope of this discussion, but we can discuss that later. Okay, so cosine similarity or cosine distance. This is angle, cosine of angle between the vectors. Now you might ask, what is the meaning of this x and what is the meaning of this y? We'll try to understand that in a while. But did you understand what I meant by words being transformed into numbers? What is the purpose of doing that? We convert words to vectors, vector representation. Okay, this process is also called as feature extraction. Okay, this vector representation is used to represent the meaning of the words. Therefore, we can use this to compare if two words are similar. How? Using cosine distance. If by some way we are able to convert the words to numbers, if we have bunch of numbers for apple, we have bunch of numbers for banana, then we can compare those numbers, we can find the distance between them and find out if the distance is less or more. If the distance is less, that means the words are closer to each other, they are similar to each other. If the distance is more, that means the words don't have anything to do with each other, the words are quite far apart. So we are representing words in a in a vector representation, or a numerical, you can say a numerical representation. Okay, guys, did you are you guys following till here? समझ में थोड़ा थोड़ा समझ में आ रहा है क्या? हाई लेवल इंट्यूशन समझ में आ रहा है? ठीक है, एक एग्जांपल इसका करते हैं। ठीक है, इसका जब मैं प्रैक्टिकल दिखाऊंगा आपको और ज्यादा समझ में आएगा। ठीक है, लेकिन एक सिंपल तरीके से मैं समझाने की कोशिश करता हूँ। ठीक है, कि सपोज दो वर्ड्स लेते हैं। ठीक है, एक वर्ड लेते हैं प्लेयर। ठीक है, एक वर्ड लेते हैं स्टूडेंट। ठीक है, एक वर्ड लेते हैं गैंगस्टर। ठीक है, इन तीनों वर्ड्स का इन तीनों वर्ड्स का रैंडमली मैंने ले लिया है, पता नहीं अच्छा एग्जांपल है या नहीं। ठीक है, प्लेयर, स्टूडेंट, गैंगस्टर, इन तीनों का हम लोग एक न्यूमेरिकल रिप्रेजेंटेशन बनाने की कोशिश करते हैं. विल ट्राई टू मेक सम न्यूमेरिकल रिप्रेजेंटेशन ऑफ दीज वर्ड्स. ओके. So how would you differentiate between player, student, and gangster? If you ask this question to yourself, if you ask this question to yourself about player, student, and gangster, let me not make player, let me make it cricketer. All of you know that these three words are very, very different from each other. All of you know. If I ask you, is cricketer, student, and gangster, are they similar? You will say, no, these are not similar. They are very different from each other. But how do you know they are very different from each other? If you ask this question to yourself, you will realize that in your mind, there are some mappings that when you think about cricketer, a few things come to your mind. If you think about a student, some other things come to your mind. If you think about gangster, something else comes to your mind. And those things do not usually intersect with each other. There might be some intersection. For example, if there is a cricket match where there is some kind of match fixing going on, there maybe gangster and cricketer can come together. Maybe if there is a very talented cricketer who is in school, so he's also a student, so maybe their student and cricketer can intersect with each other. But usually these three things are very different from each other. Okay. How that happens? It happens because in our mind there are some features, or there are some characteristics which we are assigning to these. Okay. So let me say some characteristics. Let me come up with some characteristics. One characteristic can be age. Okay. Another characteristic can be fitness. Okay. Third characteristic can be money. I'm just making it up, but money. Other characteristic can be studious or intelligent, let me say. Intelligence. Hardworking. Okay. Another can be that is, are they sincere? Okay. Like that, there can be many different features. Now, if you start assigning some numbers to them, a cricketer's age will be what? Approximately, maybe a cricketer's age can be 25. Okay. Fitness, out of 100, I'm giving them scores. Okay. So cricketer's fitness is going to be very good, maybe 95. A cricketer is going to have some money. Yes, maybe they can have some money depending on where they are playing the cricket. Is a cricketer hardworking? A cricketer is very hardworking. Okay, fine. Maybe I can give some points here, 90. And is a cricketer sincere? I don't know, may or may not be. So maybe I can give 65. If you talk about student, a student's age is going to be much less. Student's age is going to be maybe 15. Okay. Student's fitness may or may not be very good, maybe 75. Okay. Student's money is going to be very less. He's not going to have much money. So 10. Student is hardworking. Yes. Student is going to be very hardworking. So I'm going to give 98. And student is going to be sincere. Yes. Student will be sincere also. So 95. Now, if you talk about gangster, a gangster's age, gangsters are usually of very high age. Normally, if I don't know any gangsters personally, but maybe 45. Okay. A gangster's fitness, I don't think so. He's going to have bad fitness. Okay. And gangster is going to have a lot of money. So 100. And a gangster is going to be hardworking. I don't think so. So I'm going to give very less marks for hardworking. And gangster is going to be sincere. Definitely not. So I'm going to give 0. So you see what I did? I created these features. And based on these features, I have created some numbers. Okay. So if I talk about numerical representation of a word, if I talk about numerical representation of a word, then I have a numerical representation here, which is 25, 95, 80, 90, and 65. Okay. And this is 15, 75, 10, 98, and 95. And this is 45, 25, 100, 25, 0. So by using some method, now of course, these are the features that I have imagined. Usually these features are determined by a deep learning model, and we are not able to interpret what these features are. So these are just going to be x1, x2, x3, x4, and we will never know what those features mean. But we know that the numbers that are generated, okay, we will not know what these numbers represent. Here we know what are these numbers, okay, because this is an example that I've taken. But in real life, when these features or when these representations are generated, these numbers are never interpretable. We are never able to make sense of what these numbers are. But these numbers are such that they contain the meaning of the word. Okay. So when you take cricketer, so this is if x1, this is x2, and if you take x3, if you try to find distance between x1 and x2, you will get some metric. Okay. Maybe you will get cricketer and student can have some similarity, maybe 80%. So if you try to find out distance between these two, you might get maybe 80% distance, 80% similarity. And if you try to do x2 and x3, student and gangster, maybe you will get only 20% similarity because student and gangster are not related to each other. If you try to do cricketer and gangster, maybe you will get 55% similarity because gangster and cricketer can be related to each other. Okay, so if you try to find out these distances, okay, this is in 0 1 2 3 4, this is in 5 dimensions. I cannot draw 5 dimensions and show you, but if this was maybe in 2 dimensions, okay, then it would have been something like this. There can be a gangster, a cricketer here, maybe a gangster here, and maybe there will be a student here. Okay, so if you, let me not draw it like this, let me say here like this, and when you try to draw these things, you'll see that these are little bit similar, and this is quite far away. Let me draw it. I did not give it enough distance. Let me give some distance here. Okay, so you can see these are, sorry again, you can see here. Okay, now what are these x and y? Maybe this x and y can be, this can be age, and this can be maybe money. Okay, I am able to draw only two, but actually there are five: age, money, fitness, hardworking, sincere. But I cannot draw those five. So I've just taken two, and based on the two, I have drawn this something very similar. And these are basically numbers. So these are two dimensional. These are, I hope you understand basic coordinate geometry. So these are two dimensions. And in these two dimensions, we are able to see that this and this are very close to each other. And this is quite far from each other. So because of this angle, okay. So this is the angle that we are measuring. So how are embeddings generated? We don't want to get into that. I gave you a very oversimplified example, but whatever happens is very close to this process, except that we don't do it manually. A deep learning model does it. But end of the story, we get a vector representation. We get a vector representation. We get a vector representation. Now, if we have a vector representation, we are able to find the similarity between any two vectors. So what will happen here? If I take this example, what I'm going to do, let me take this example. What I'm going to do, I'm going to take this whole thing. Okay. Okay. I'm going to take every single sentence. I'm going to take every single sentence here. Okay. And I'm going to, from this document, I'm going to create a knowledge base. And now I'm not going to call it knowledge base because now you know that this knowledge base is going to be nothing, but this is going to be a vector representation of everything in the document. Which means it's going to, if there are 5 sentences, then there are going to be 5 vectors here. Okay. So if you see this sentence, then for corresponding to this sentence, I'm going to have some numbers. And corresponding to this sentence, I'm going to have another set of numbers. 3, 4, 8, 9, 16. Here I'm going to have maybe some numbers which are going to be 10, 16, 20, 35, something. Okay. Rajiv is an engineer. I'm going to convert this also, this sentence also, to a number, set of numbers or set of vectors. Okay. And all of this will be ready-made. You don't have to do any work manually. 10, 16, 18, 8, 4, some numbers. And similarly, I will have Rajiv is married. So I will have some numbers here. 6, 4, 3, 2, 1, something. Okay. So all the 4 sentences, I have converted them to numbers. And this, I'm going to call it as my vector store. Or you can also now, otherwise, till now, I have been mentioning it as knowledge base. So all my knowledge base is now vectorized. Okay. The question that I have, the question that I have, the question that I have, that also will be vectorized. So I will have a query. Okay, whatever is the query, what is Rajiv's favorite food? This also I'm going to vectorize. What I'll do, I'll vectorize this also. Whatever process I used to vectorize these things, same process I will use to vectorize this, and I'll create a vector for this also. So this vector will be maybe 10, 17, 21, 36, something like this. Okay. So now what I will do, I will check, I'm going to check that this is my query vector and these are my document vectors, and what is the similarity between this and this. So here I'm having 10, 17, 21. Here I'm having 10, 16, 20. So this is quite similar. This seems quite similar. So here probably I'll give a similarity score of 90%. Okay. Then here I'm having some vectors that are representing cricket. Cricket and food, they might be little bit related to each other. So here maybe I will get some similarity of 75%. Okay. Here Rajiv is an engineer. Now engineering and food, they don't have much relationship. So maybe here I will get 40%. And here I'm having Rajiv is married and there is talk about food. So in marriage, there is food. So there can be some relationship between marriage and food. So maybe here I will get 48%. Now I can find out very easily that if I want to answer this question, Rajiv's favorite food, based on these documents, then the relevant part of this document is this part because it is having 90% similarity. So this part is corresponding to this sentence. So what will this do? This is going to give me this whole process, I will say this whole process. Okay, this I'm going to say these are embeddings. Okay, this is my text documents. From text documents, we are creating embeddings. We are having question. The question also is created into embeddings. Embeddings, we can do a comparison, and based on that, we will get context. So context is going to be what? Context is going to be Rajiv likes pasta. This is the context, and this whole process is going. We are going to call it this entire process as the retrieval process. I've oversimplified it a lot, but I just wanted you to have a high level know-how of what is what. And then, of course, if we get a chance, we'll go into depth also of how actually these embeddings are coming, what kind of similarity scores are there, how this context is coming. Maybe there are multiple documents, so we can get maybe 4 or 5 different documents in context also. Here I've oversimplified it and we are getting one context here. Okay. So now Rajiv likes pasta. It becomes a context for my query, for my question. Now this query and this context both are going to go into, this is going to go into, this is going to go into my, this will go into my LLM. This will be, there will be question plus context. Okay. Now this LLM will give me an answer. Okay. This part I'm going to call it as the generation part. We are having the retrieval process. This question plus context, which is coming together. This part I will call it as the augmented prompt. Okay. So we did retrieval, we did augmentation, and then here we are doing generation process. And finally, we will get our answer. So answer will be what? Answer will be what? Answer will, you will get something like this based on the context. This LLM will say based on the context, Rajiv enjoys pasta. He eats pasta. Something more. Okay. But This is the response that we are going to get. Okay. So this is the whole high level understanding of embeddings and how retrieval is working. Okay. Guys, did you understand how good the query should be to get good answer? Query can be anything. We cannot question the query. Query can be whatever you ask. But how good are the embeddings? That is a subjective question. That how do we evaluate if the embeddings are good or not? Or in fact, when we say similarity, that itself has a very deep connotation. How to decide which embedding is good for the use case? So there are a lot of embedding models. Embedding, how to decide which embedding model is good for the use case depends on what is the use case. Okay. So suppose if you are using general context, okay, suppose you are, I'll give you an example. So embedding models are also trained on some data. Okay. Embedding models are also trained on some data that is publicly available. Okay. Data that is publicly available. So suppose if you ask embedding model, suppose you have watched a movie called Bahubali. Okay. And suppose LLM is not, has not seen the information about Bahubali. And if you ask it to find the similarity between uh, Bahubali and Bhalal Dev, okay, if the document, if the model, embedding model, which is trained on some data, that data did not include Bahubali script, then it is not going to give you proper similarity, because Bahubali and Bhalal Dev, they are quite similar because they are in the same movie, they are in the same, they are brothers. So it will not be able to give you a good similarity score, because in general knowledge outside of Bahubali, there is no meaning to the word Bahubali and Bhalal Dev. Okay. But if you train an embedding model on the script of Bahubali, then you will get a very good similarity, right? So it depends on which data, what is, which domain your query is, and which domain your data has been trained. So if you are very much deep into, say, for example, medicine, okay, and if you're trying to find similarity between two very specific drugs, and the embedding model is trained on maybe financial data. So in financial data, they will know about the embeddings will be such that they will understand about stocks and options and investment and bonds and securities and all those things. And you are trying to find similarity between two words, which is from a different domain, which is from a medicine domain. So it is not going to work very well. So usually what we do, we train embedding models on our use case or our domain in which we are working. But the embedding models which are available in the market, those are general models which are generally good for everything. Just like OpenAI embeddings. If you use ChatGPT, normally you get information about everything. But if you want to go deep into, very deep into some niche subject, maybe ChatGPT might fail. Usually that does not happen. But if you go into very depth of a particular subject, very niche subject, then ChatGPT might run out of its depth also. Okay. Yes, we can train our embedding models. That's the whole point. We can train our embedding models. If I had the scope, I would have shown you. We usually train embedding models in our NLP discussions. So we can train our embedding model. For example, you can train, I usually give a demo where I train an embedding model on a Harry Potter movie. Okay. So normally if you ask any embedding model which has been trained on maybe some law-based data, okay, some legal information, which has seen only legal data, there if you go and ask what is the similarity between Harry Potter and Voldemort, it will not be able to tell. It will be confused. It will give you some random answer. Okay. But if you ask it on an embedding model, which is if you ask it on an embedding model which is specifically trained on fantasy books or which is trained on the Harry Potter book, there it will give you a very good enriched embedding for the words Harry Potter or magic or Hogwarts, like that. So embedding models are also coming from some context, from some corpus. And generally the corpus is common information on the internet, but the corpus can also be some specific corpus if you want very very specific results. It's like rag on embed, no no, ऐसा नहीं है. एम्बेडिंग मॉडल एक अपने आप में एक सेपरेट सब्जेक्ट है. एम्बेडिंग मॉडल का काम सिर्फ इतना है कि हर वर्ड, वोकैबुलरी में जितनी वर्ड्स है, हर वर्ड का एक न्यूमेरिकल रिप्रेजेंटेशन हो, और वो न्यूमेरिकल रिप्रेजेंटेशन ऐसा हो जिसमें उस वर्ड का मीनिंग इम्बाइब्ड हो. ठीक है. ताकि आपको अगर एप्पल का वेक्टर मिले और आपको अगर बनाना का वेक्टर मिले, तो दोनों क्योंकि एप्पल और बनाना सिमिलर है, तो दोनों के वेक्टर्स भी सिमिलर होने चाहिए. That is the whole job of an embedding model. एक RAG में, what is the role of an embedding model? The role of the embedding model is to help in the retrieval process, to find which part of the document is similar to the question. दैट सिमिलैरिटी वाला काम एम्बेडिंग से होता है। एक बार वो सिमिलैरिटी निकल गया और हमें कॉन्टेक्स्ट मिल गया, उसके बाद एम्बेडिंग का कोई काम नहीं है। उसके बाद यू टेक दैट कॉन्टेक्स्ट, यू पुट इट विद द क्वेश्चन एंड यू गिव इट टू द एलएलएम, एलएलएम विल गिव यू द आंसर। Yes, we do that using NLTK. We have a lot of if you have done NLP, then if you have used the Spacey library, it will have some embedding models. And nowadays, Hugging Face, if you go, you'll find a lot of embedding models. OpenAI has their embedding models, which is very very good. So normally people will use embedding models from Gemini or OpenAI. But high level, what does the embedding model do? It will convert words to vectors. That's the high level idea. Guys, did everyone understand? Retrieval and embedding process. I'll definitely show you how this is working. But this was like a very high level layman introduction to what is RAG.
अच्छा, एक चीज है कि जैसे ये
Hmm.
तो इम्बेडिंग एक कॉन्सेप्ट हो गया, लेकिन इसका भी मतलब जैसे मॉडल का कुछ रिक्वायरमेंट है क्या कि ये मतलब डेटा का साइज, इतना डेटा साइज पे मॉडल रन करेगा, इससे ज़्यादा डेटा साइज में मतलब कि हमको ये
नहीं,
मॉडल चाहिए?
डेटा आपके पास जितना जितना पैसा है, आप जितना रिसोर्स खरीद सकते हो, आप उतना ज्यादा बड़े डेटा पे आप उसको ट्रेन कर सकते हो।
मतलब ये सारा चीज़ एप्लीकेबल रहा, जैसे कि स्केटलन लाइब्रेरी है, तो
हम्म।
उसमें क्या है कि 10 GB से ज़्यादा है उसमें नहीं यूज कर सकते हैं।
नहीं नहीं, साइकिल लर्न नहीं यूज होगा इसमें। इसमें डीप लर्निंग मॉडल्स यूज होते हैं एम्बेडिंग्स के लिए।
हम्म
ठीक है। तो नॉर्मली आपके पास जैसे कोई बुक है, कोई पीडीएफ है, तो उसके ऊपर आप एम्बेडिंग्स बना सकते हो। बट जनरली जब एम्बेडिंग्स बनते हैं तो बहुत ही बड़े कॉर्पस के ऊपर बनती है। बहुत
ओके।
बहुत हाई वॉल्यूम ऑफ डेटा के ऊपर बनती है। ऑब्वियसली आप सोचो ना कि इंटरनेट पे कितना डेटा है, उस सारे डेटा के ऊपर आपको अगर कोई ट्रेन करना है, तो उसके लिए बहुत सारा आपको रिसोर्स लगेगा, बहुत सारा आपको कंप्यूटेशन लगेगा। तभी तो
हम्म।
ओपन एआई ने वो काम किया है और वो मॉडल आपको अवेलेबल है और आप पे करके वो मॉडल यूज करते हो।
राइट।
बट वो मॉडल कैसे ट्रेन होता है, हाउ दोस मॉडल्स आर ट्रेन्ड, दैट इज नॉट what we are interested right now. Of course, we will learn that also. But we want to understand what is the output, and whatever the output is there,
नहीं,
that
लेकिन
how that is being used.
ट्रेन करने के बाद ही ना एक्यूरेट मॉडल रहेगा ना, मतलब जो मेरे को चाहिए।
नहीं, आपके पास जेनरिक एम्बेडिंग्स अवेलेबल है मार्केट में,
हम्म।
जो जनरल डेटा पे ट्रेंड है। तो आप जो भी करोगे वो जनरल ही तो होगा ना, आप एकदम ही कोई नीश काम तो नहीं करोगे। अगर करोगे तो उसके ऊपर आप अपना सेपरेट एम्बेडिंग मॉडल्स ट्रेन कर सकते हो। बट जनरली जो मार्केट में अवेलेबल है, जो ओपन एआई, जेमिनाई, क्लॉड, ये लोग जो एम्बेडिंग्स मॉडल अवेलेबल कराते हैं, ये जनरल डेटा पे ट्रेंड है, इंटरनेट पे जो भी इंफॉर्मेशन उस पर ट्रेंड है। दैट इज गुड इनफ फॉर मोस्ट यूज केसेस।
तो ट्रेनिंग का मतलब यही होगा ना जो हम लोग डिसीजन ट्री में करते थे,
नहीं
रैंडम
नहीं
सर्च।
नहीं नहीं, इसका प्रोसेस दूसरा होता है, ये डीप लर्निंग प्रोसेस होता है,
हाँ, जैसे
अनसुपरवाइज प्रोसेस होता
डीप
है। इस
लर्निंग में ईपॉच करके जो होता था वो
इपॉक,
बोले।
हाँ, यस, आपने इपॉक सुना होगा। इपॉक इपॉक यूज होता है। ठीक है, ये अनसुपरवाइज लर्निंग होता है। आप जो बोल रहे हो डिसीजन ट्री, रैंडम फॉरेस्ट, ये सब सुपरवाइज मेथड्स है।
ओके ओके।
एम्बेडिंग के जो प्रोसेसेस होते हैं यूजुअली अनसुपरवाइज होते हैं, सुपरवाइज भी होते हैं। बहुत सारे प्रोसेस हैं, मुझे भी हर प्रोसेस के बारे में नहीं मालूम है। आई डोंट नो about every process, but usually these processes are unsupervised process. I can talk about that separately, but the problem is that you need to know deep learning in order to understand that. Otherwise, you will not be able to get that. And I don't want to get into that discussion. I want to be more on how to use this to build something. That is my intention for these sessions. Guys, would you like to see one implementation of this next time, where we will actually take a document, we'll try to create a RAG? We can do that in the next session. If you have any questions, please let me know. I'll definitely try to implement this, all of this process. There are few more things here, which I will explain, and then we will try to actually implement it using LangChain. So if you go here, there is a very good library you will find, which is
ये
LangChain.
आप पूरा पढ़ा होगा क्या, एजेंटिक है और एलएलएम सारा?
Sorry.
एलएलएम में जैसे तीन चार है ना, क्रू एआई और भी लैंगचैन,
हाँ, सब
सारा
सब
डिस्कस करोगे?
जितना टाइम मिलेगा उतना डिस्कस करेंगे। ये कोई स्ट्रक्चर्ड डिस्कशन नहीं है, बट आई विल ट्राई टू कंक्लूड इट सो दैट थिंग्स हैव अ कंक्लूजन, प्रॉपर कंक्लूजन। बट सब कुछ डिस्कस करना पॉसिबल नहीं है। बट यू सी हियर, इफ यू गो हियर ऑन LangChain, this is the library that usually we will use. And if you go to docs, somewhere you can search for a RAG, or you can search maybe embedding model, or you can go to OpenAI and look for embedding models. We'll see. I will try to do one better implementation where we'll do everything step by step. You can see here. See, vector embeddings. This is by OpenAI. Okay. Similarly, others will also do. This is chargeable. They will charge you some money for this. But and there are models available for free also. I'll try to give demo of everything. So see, these are vector embeddings. Learn how to turn text into numbers, unlocking use cases like search. See, this is what we were discussing. Text into numbers. This is like तीन वर्ड्स में अगर समझाना है एम्बेडिंग्स क्या है तो इट मींस टेक्स्ट को नंबर्स में कन्वर्ट करना. ओपन एआई टेक्स्ट एम्बेडिंग्स मेजर रिलेटेडनेस ऑफ टेक्स्ट स्ट्रिंग. यही तो बात कर रहे थे हम लोग, रिलेटेडनेस ऑफ टेक्स्ट स्ट्रिंग. हाउ टू टेक्स्ट आर रिलेटेड mathematically means a mathematical metric to determine how those two strings are related to each other. If I give you 2 points, you can find the distance between them because points are represented by coordinates. इसका coordinate है 2 3, इसका coordinate है 10 and 20. So इसका बीच में आप डिस्टेंस निकाल सकते हो. लेकिन अगर मैं आपको बोलूं एप्पल और मैंगो, तो इन दोनों का डिस्टेंस आप कैसे निकालोगे? कोई सेंस नहीं बनता है. एक स्ट्रिंग है, टेक्स्ट है, उसका क्या डिस्टेंस कैसे निकलेगा पता नहीं. लेकिन अगर इस एप्पल को मैं किसी तरह एक नंबर में कन्वर्ट कर दूं, 2 और 3 और 15 और 16, तो अगर नंबर में कन्वर्ट हो जाएंगे तो फिर हम लोग इसके ऊपर डिस्टेंस निकाल सकते हैं, इसके ऊपर मल्टीप्लीकेशन कर सकते हैं, इसके ऊपर एडिशन कर सकते हैं, इसके ऊपर सब कुछ कर सकते हैं. जितना भी हमने मैथ सीखा है वो सारा कुछ कर सकते हैं. तो होल आइडिया इज टू कन्वर्ट टेक्स्ट इनटू नंबर्स, एंड दैट इज व्हाट एम्बेडिंग्स मीन. वेक्टर्स मैंने वर्ड यूज किया था. वेक्टर्स कुछ नहीं है, वेक्टर्स बस ये नंबर है. जैसे ये 2 3 है, इसको मैं ऐसे लिख दूं, ये हो गया वेक्टर. आपने 12th स्टैंडर्ड में वेक्टर्स पढ़ा होगा, बट वी डोंट वांट टू गो इनटू दैट मच डिस्कशन. ओके, सो यू सी where it is used. There are huge applications of embeddings. Classification models, if you're working on learning ML, they're also, you're going to use embeddings. If you're doing some unsupervised clustering methods, there also you will use embeddings. Anomaly detection, you will do uh, embeddings. Recommendations, clustering, classification, where text strings are classified by their most similar label. Okay, so embedding is a vector of floating point numbers. Distance between two vectors, measure their relatedness. Small distances get high relatedness and large distances suggest low relatedness. यही मैं बोल रहा था. Cosine similarity and cosine distance. Similarity is just the angle, that theta. अगर angle is less, if the angle is less, then the distance, if that, this is, sorry, this is similarity, ये नहीं है. This is the theta. Okay, so if the theta is less, then similarity is more. If the theta is more, अगर एंगल ज्यादा है इसका मतलब सिमिलैरिटी कम है. एंगल ज्यादा है मतलब वर्ड्स आर far away from each other. Okay, so you can see here embedding. Embeddings is a vector list of floating point numbers. Distance between two vectors measure their relatedness. I hope all of you are able to relate. Okay, and how to get embeddings? यहाँ पे is very simple. You call the OpenAI API and यहाँ पे ये JavaScript का कोड दिखा रहा है, इसको Python कर देते हैं. ठीक है, it's very simple. You can come here and you can call, एक simple line of code है यहाँ पे, और यहाँ पे आप text, अपना text दोगे, और which model you want to use. So this is a model from OpenAI which is called as text embedding 3 small, and once you do this, you will get a, whatever text you have given here, for that text you will get a bunch of numbers. You see here, this is also, they're also giving an example only, but you can see here, ये देखो यहाँ पे इन्होंने एक टेक्स्ट दिया है, मॉडल दिया है, एंड सी दीज आर सम नंबर्स हियर. सो दीज नंबर्स आर बेसिकली द एम्बेडिंग्स. दीज आर फ्लोटिंग पॉइंट नंबर्स. मैंने जब एग्जांपल दिया तो मैंने वहां पे 10 3 20 ऐसे लिख दिया था, बट एक्चुअली दोज आर डेसिमल नंबर्स, और वो डेसिमल नंबर्स काफी ज्यादा प्रिसीजन के होते हैं. यू कैन सी हाउ मेनी डेसिमल पॉइंट्स आर हियर. ओके, एंड दीज नंबर्स विल एक्चुअली रिप्रेजेंट द मीनिंग, एंड द लेंथ इज 1536. तो मैंने जो बनाया था उसमें मैंने 5 बनाया था. 5, द वेक्टर का जो लेंथ था वो 5 था, 1 2 3 4 5. यहाँ पे द लेंथ इज 1536. Okay, and for some other model it can generate vectors of length 3000, which means every word will have a vector with 3072 numbers. Okay, so I will give a demo on all of this. Today's intention was just to, you can see here, all these are different models which are available by OpenAI, and what are some use cases, and you can see some code you can see here, and I'll try to do this exercise next time in the next class. But I hope all of you got an introduction to retrieval augmented generation, what it is, where it is used, how retrieval happens, how augmentation happens. Right, guys? Let's conclude for today. And then in the next class, we will try to do implementation, and we'll try to build a simple RAG pipeline. And then I'll also discuss about agentic. And there is something called as a RAG workflow, and there is also agentic RAG. So agentic RAG is slightly different. So if we can continue, then definitely I'll also talk about that. And then we'll try to do some small project. I'll try to build some chatbot. We'll also try to deploy it so that we can see the uh, end-to-end life cycle of how such a project can be made, it can be deployed, it can be monitored, and you can share it with your friends. They can also interact with your RAG flow, and they can ask questions. You will see a lot of products before ChatGPT. Uh, they used to have build products where you can upload a PDF and you can chat with it. And there were a lot of people who are actually building that product. And ChatGPT or OpenAI came up with the product. They enabled a feature where you can upload a PDF and you can chat with the PDF. That itself is a retrieval based generation. So all of those startups actually they faced a very difficult time. But there were a lot of projects. So we'll try to build one project like that where we'll try to upload a PDF. You can upload your resume, you can upload your bank statement, you can upload your resume, CV, or you can upload your whatever. Uh, some financial records, and then you can ask question that am I doing well, what are my expenses in this domain, how can you how can I optimize this. So this type of products are there. A lot of products are there which will kind of look at your SMS, they will look at your bank statement, and they will make a summary of your expenditures. So we'll try to do something like that. Okay, all of these are based on RAG systems. So we'll see how things go, but my intention is to at least show you a typical RAG implementation using LangChain and OpenAI. Okay, guys, we'll stop here today and then we'll continue in our next session. किसी को कोई क्वेश्चन है? Does anyone have any question in what I discussed? Let me stop the recording.
एक बार थोड़ा सा एक रोड मैप मतलब एक बता सकते हो कि उसमें मतलब कि लैंग चैन बोल रहा हूँ, एजेंटिक एआई और इसमें एलएलएम में कौन कौन सा मॉडल?
एक मिनट मैं रिकॉर्डिंग 1 मिनट स्टॉप कर रहा हूँ, उसके बाद डिस्कस करते हैं.